Hello everyone, have you not started your physics preparation yet? Your exam is tomorrow and you are thinking that there is too much to study, what to study. I just want to pass, I just want to score 45-50 marks in the upcoming midterm exam. Then this is the video where I am going to discuss all the important questions from your PU2 midterm syllabus so that you can at least score minimum 45 plus marks. So let's start with the questions. I will not delay anything because this is a very short video where you will get all the important questions answers at one place. So first question, state and explain Coulomb's law in electrostatics. You have to write the statements properly. Coulomb's law states that the electrostatic force between 2 point charge is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of the distance between them. It acts along the line joining the charges. Mathematically, you have to write the mathematical formula. Also, Q1, Q2 are point charges. Epsilon naught is permittivity. R is the distance between the Q1 and Q2. If the same question comes as a vector form, then what you have to do, you just have to change one small thing. You have to add one vector sign over here and one R vector over here and add a ray diagram. Sorry, not ray diagram, one diagram. Q1, Q2, and you have to draw this R cap vector. Okay, R cap, it will be R cap. So this is how you can just convert the same answer into vector form question. Okay, same question, same answer. Only thing you have to show it in vector form. Now next question, write any three properties of electric charge. Additivity of electric charges. Charges are additive in nature. Write down at least one sentence for each properties. Quantization of charges. All charges are integral multiple of smallest charge E. Conservation of charges. Total charge in an isolated system is conserved. Right. Next, write three properties of electric field lines. Another important question. Electric field lines may start from positive charge and end at negative charge. Two electric field lines are never intersect each other. Electrostatic field lines do not form any closed loop. So these are the three basic points that you have to remember. On what factor does the capacitance of a parallel plate capacitor depend? So here you have to write down the formula. C equals to A epsilon naught by D. So it is directly proportional to area, inversely proportional to the distance between the plates, directly proportional to the dielectric constant. So if you add a dielectric constant over here, then it is proportional to dielectric constant. This is optional point. So if you mention this point, then you have to add this K over here. Next, write two properties of equipotential surface. It can be two properties, it can be three properties, any one of them. As it is, it can be a 3 marker as well as a 2 marker question. No work is done moving a test charge over an equipotential surface. Electric field is always normal to the equipotential surface at every point. No two equipotential surfaces can intersect each other. Mention two limitations of Ohm's law. Ohm's law is applicable only if all the physical conditions remain same. Ohm's law is not applicable at very low and at very high temperature. Ohm's law is not applicable to non-ohmic devices like semiconductor devices, discharge tube, etc. So you can remember one of them, that is semiconductor devices, and mention them as non-ohmic devices as a whole. Next, state and explain Biot-Savart's law. Now for this question, you have to practice this diagram. Very simple. Any random curved line is fine. You have to take one point and then you have to draw a line which is tangential to the point that you have taken, and then this is the direction which is current element's direction. Now angle between the IDL and theta is given by theta, right? Now you have to mention that the magnitude of magnetic field at any point P due to the current element is dl is given by dB proportional to current I. dB is the small value of magnetic field. Okay, dB is the small value of magnetic field due to this small element. You are not considering the entire wire. You are only considering a small portion. So the magnetic field due to this small portion IDL is basically given by this formula. So you have to understand the formula as well. So dB is proportional to I, dB is proportional to the length dl, dB is proportional to the sine of this angle theta, dB is inversely proportional to the square of the distance. Okay, so it is 1 by r square, and combined form is dB equals to mu naught by 4 pi I dl sin theta by r square. This is a 3-marker question, and you have to draw the diagram and mention all the points properly to get full marks. Next is, what is Lorentz force? Write its expression and explain the terms. Very common question from the moving charges and magnetism chapter. Force acting on a moving charge particle in the presence of electric and magnetic field is called Lorentz force, and here F is given by Q into E plus Q into V cross B. So this is the expression for Lorentz force. Here you have to mention Q is the charge, E is electric field, V is velocity of the particle, and B is the magnetic field. Remember, everything is vector, so be careful and do not mess this up. Okay. Next is, how can a galvanometer be converted into a voltmeter? Now you have to write that a voltmeter should have a very high resistance as it is connected in parallel in the circuit. This is very important statement. A galvanometer is converted into a voltmeter by connecting a suitable high resistance in series with it. This way overall resistance of the voltmeter remains high, and then you have to draw this diagram. I have taken it from your textbook, so you can skip this RG part. You can directly write G plus this R, okay, and they are together called voltmeter. Now next is, how can a galvanometer be converted into an ammeter? Similarly, an ammeter should have very low resistance as it is connected in series in the circuit. Series in the circuit means overall resistance has to be low, parallel means overall resistance has to be high. This is achieved by connecting a suitable low resistance S in parallel. This small resistance is called shunt with a galvanometer. This way the overall resistance of the ammeter remains low and the galvanometer is converted into an ammeter. Then the diagram is, as usual, is compulsory to write equations. Everything is not compulsory. If you know the equations, if you write it, good. If you don't know the equations, you just simply draw the diagram and write the statement. That will be considered as full marks. Write 3 differences between diamagnetic, paramagnetic or ferromagnetic. Any two will be given. One of the difference generally comes each and every year. Almost all districts they give either difference between diamagnetic and ferromagnetic, diamagnetic and paramagnetic, paramagnetic and ferromagnetic. One combination will definitely come. So how to write this? So first you have to write the property. Okay, check this diagram carefully. So first you have to write the properties of the materials. Okay, magnetic behavior. What is magnetic behavior? For diamagnetic, these are weakly repelled by magnetic field. What is the magnetic behavior of paramagnetic? They are weakly attracted. So diamagnetic weakly repelled, paramagnetic weakly attracted, ferromagnetic strongly attracted. Okay, even if you just mention weakly repelled, weakly attracted, strongly attracted, that is sufficient if you mention this property. Next is magnetic susceptibility. Okay, how it is susceptible to magnetic field? Have a small negative magnetic susceptibility, have a small positive magnetic susceptibility, have a large positive magnetic susceptibility. Now last point is effect in a magnetic field. Now if it is a 2-marker question, 2 difference is sufficient. If it is a 3-marker question, you have to write 3 differences. Effect in a magnetic field induces a magnetic moment in the opposite direction of the applied field, induces a magnetic moment in the same direction of the applied field, induces a strong magnetic moment in the same direction as the applied field. So remember that for ferromagnetic it is all very, very strong. For paramagnetic it is positive but all very, very weak. For diamagnetic it is negative but all very, very weak as well. Now next is derive the expression for motional EMF induced in a straight conductor moving perpendicular to uniform magnetic field. So first step is to draw this same diagram, indicate what is the velocity with which it is moving. Now what you have to do, you have to first step is to calculate the area of this. So what is the area of a rectangle? Length into height, or length into breadth. Okay, you can consider this as length, this is as breadth. So what is the area of the rectangle? Area of the loop is given by A equals to L into X. Okay, L into X is the area. Now we have to use a very simple concept that is called flux. what is magnetic flux. Magnetic flux is given by the magnetic field times area. So it is magnetic field times area. Generally there is a cos theta over here, but because magnetic field is actually going into the plane of the loop, so in that case you don't need to consider the cos theta value is 1. Okay, so this cross mark signifies, the cross marks are also important. This signifies that magnetic field is going into the page of the paper. So if you draw this diagram, you have to draw the cross, which is very, very important. So phi b is equal to b dot a, or magnetic field is given obviously into L into X. So this is the magnetic flux passing through this rectangle. Now magnetic flux, when you change it, then what happens? A magnetic EMF is induced. Now how we are changing it? By bringing this slider closer. Okay, so when you bring this slider closer, what happens is that the area changes. Okay, basically the X value here changes, because as you are moving here, the X value is decreasing. Okay, that's why what happens is there is an induced EMF. So induced EMF, magnitude of induced EMF, I will say, is basically given by d phi by dt. Okay, so d phi by dt basically represents, here I have to mention magnitude of induced EMF. Very, very important to mention the term magnitude. Okay, so here it will be, you have to put d dt of, so phi b is the function and this is the value of the function BL into X. Now magnetic field here is not changing, it is constant, it is given, right? You have to mention that as well. In this case, that magnetic field is given here as B. Okay, now magnetic field is constant, the length is constant, it is not changing, only thing which is changing is this X. So if anything is constant, that comes out of the differentiation, we know that, so it will be dx by dt. Now if you just go back in your first few concepts, that dx dt is the rate of change of displacement. Okay, rate of change of displacement. Rate of change of displacement means which is exactly equals to velocity. So it will be b l v. Okay, sometimes we write this as b v l. Okay, so b v l is the expression for induced EMF in this particular circuit. Okay, so just remember this derivation, very easy derivation, nothing much to do. Calculate the area, differentiate it, and then just put this dx by dt as v, you will get the expression. Now next question, the expression for electric potential at a point due to a point source charge. So this is a little tricky, but very, very, very common. Almost every year this question comes. This is the 5-marker derivation. Previous one was a 3-marker derivation. So here we have a point charge. Take this charge as capital Q. Take a point as point P, and then extend that line, and in between you take 2 points A and B. Now the definition of electric potential is the work is that you do to bring a charge from infinity to a point P. The work that you do is basically the potential at that point. So what we have to do, we have to take a unit positive test charge. So the test charge is 1. We are not considering anything else. Directly plus 1 you put over here. The distance of the point P is basically r, and distance of the point B is say x. This small distance is dx. This is a very small distance. So remember every step properly. Diagram is compulsory for this derivation. Okay, so you have to remember the steps properly so that you don't make any mistake. In derivation, derivations are easily scoreable, very easy scoreable, 5 marks you can get. Now what you have to do, first you have to construct a differential and then integrate it. Okay, that is the step, how to construct a differential. So at this point we have a plus unit charge. Suppose the unit charge which started at infinity came over here. Now what we are trying to find, what is the force acting on it due to this source charge. This is called source charge. Okay, so due to this source charge, what is the force acting on it? The force acting on the plus 1 charge can be given by Coulomb's law, K capital Q plus 1 divided by x square, right? Q1 Q2 by r square, right? So you have just remember that now this is the force due to the source charge. Now if you want to move the test charge, then you have to apply a force which is equals to this force but in the opposite direction. Okay, suppose this is plus, so the actual force will be away from, but you are bringing it in this direction. So in that case, what you have to consider is that the external force that you are applying, should be negative of the force which is being applied by this source charge, always. Okay, so it will be minus kq by x square. So this is the external force that you have to apply or I have to apply to move the charge. Work done means the work that we are doing. Whatever we are doing is positive. That is how physics always goes on, right? Now what is the work done? The small work done to bring this charge by a small distance dx. Okay, now we are considering that this small charge is being brought from B to A by this external force that we are applying. And what is the work done? The formula for work done is very simple. If you remember it from your first PU again, it is F into X. F into X, that is force into displacement. In this case it is not F into X because the displacement is only dx, so it will be F into dx. Okay, so this is the small work done. Now put the value of F external, it will be minus kq by x square into dx. Okay, now what you have to do, you have to calculate the total work done. To calculate the total work done, you have to integrate the same thing, kq by x square dx. Now what will be this is in physics, whatever integration we do, 99.9% it will be a definite integration. So if you have not yet studied definite integration, I will help you out, don't worry about that. So definite integration means you have to give it a limit, okay, starting point and ending point. So according to the definition of electric potential, we have to start at infinity and we are trying to find the electric potential at this point P. Okay, so this is our starting point, this is our ending point. So at starting point the distance was infinity, at the ending point the distance is only r. So this is how we do the definite integration. Okay, so now take the negative sign out of the integration, negative sign is out. Q is also constant, K is Coulomb constant, Q is here given at least, so we can take KQ out of the integration. Integration only depends on the variables. So what is varying over here? Dx by x square. So x is varying, so that's why dx is given over here. A limit you have to write it like this. So limit you have to write in each and every step. Now integration dx by x square, I hope you have all done. If you don't remember, I am just here to remind you as well. Dx by x square can be written as x to the power of minus 2 dx. So that means it will be x to the power of minus 2 plus 1 divided by minus 2 plus 1. So that is basically x to the power of minus 1 by minus 1, or it is minus 1 by x. Okay, so dx by x square is minus 1 by x. We will put that over here. So it will be minus kq. Integration is done. So it is minus 1 by x. And the limits, what happened to limit? We put it on now right hand side. So it started on our left hand side. Now after the integration is done, we will put on our right hand side. Now there is a negative sign outside, there is a negative sign inside. You can take this negative sign common. So negative becomes positive and you get kq. Okay, so the negative sign is basically common and cancel each other. Now what about negative infinity to r? So first you have to put the upper limit. This is called the upper limit, the final point. Final destination is called upper limit. So first we have to put upper limit instead of this variable. Minus is common, so we are not writing the minus. So instead of this x variable, we have to put the upper limit value, that is r. Okay, if it was x square, then we have put r square. If it is x cube, then we have put r cube. So whatever value is given over here, the same variable x will be replaced by the upper limit. Whatever polynomial is there, don't worry, you just need to replace x with this value. Whatever power is there, addition is there, that will be kept as it is. Okay, so 1 upon r minus the same thing with the lower limit. This negative sign is because of this definite integration property. Okay, so the negative sign will come and now you have to put the lower limit. This is the lower limit, starting point. Starting point is called lower limit. Now, what is the value of 1 by infinity? Okay, so you have to know that 1 by 0 is equals to infinity, right? So, if you divide any number by 0, you get infinity. So, 1 by infinity is actually equals to 0. Okay, any number divided by infinity is always 0. So, now put the value. So, we get kq by 1 by infinity goes to 0, only r is there. So, we will put kq by r. Now, do not end it over here, k has a value, Coulomb constant. So, it is 1 by 4 pi epsilon naught q by r. So, this is the derivation of electric potential. So, now you have to write W equals to V. So, that is equals to this same value. Okay? You have to write it here. That is how you conclude your derivation. This is just extra, you do not need to show it. This is just an extra just to explain the derivation. Now, next, another derivation, arrive at the balanced condition of Wheatstone bridge using Kirchhoff's rules. Another very important and most expected question. So, first you have to start with the diagram. Okay. So, diagram you have to, how to draw the diagram, I have not using any pre-drawn diagram, I am drawing it so that you know how to draw it. So, first you take these 4 points and then join them and add some resistance over here, use the scale so that you can draw it properly, unlike me. Okay. And then you have to draw a galvanometer over here, add them, and lastly but not least you have to add a battery over here. Okay. Now, this say P, this say Q, this say R, this say S. Okay. Current through P is shown here as I1. Now, at balanced condition, we have to mention that anyway, at balanced condition Ig equals to 0. So, no current passes through the galvanometer. So, Ig equals to 0. So, current through this galvanometer is 0. If current through this galvanometer is 0, I1 current goes here, 0 current comes out. So, whatever current I1, the same current will pass through R as well. Okay. Similarly, if I2 current comes over here, the same current I2 will pass through S as well, because current through galvanometer is 0. So, current through P and Q will be same, and current through R and S will be same. Okay. Now, what we have to do, we have to name this so that we can solve it properly. A, B, C, D. Let me name it like this. So, first we will take this loop A, B, D, A. Whenever you are writing the name of a loop, remember that this is the sign of a loop, A, B, D, A. So, starting and ending should be same, because your loop means what? You are starting from A, we are going to B, you are coming to D, and then going back to A, right? So, A, B, D, A represents this closed loop. So, now we will applying KVL, Kirchhoff's voltage law or Kirchhoff's loop rule. So, if you go in the direction, so we are going in the direction of current. If you see the arrow of the current represents in this direction. So, we are going in the direction of current. The resistance is given by this value P. So, first we have to write the resistance, then the current. If we are going in the direction of the current, then it will be positive. In case we are going in the opposite direction, then it will be negative. Now, from B to D, there is no current, so it will be 0. Okay, no current means 0, 0 into G is 0, so it will be 0. Plus, now we are coming from D to A. So, D to A, when we are coming from D to A, if you see that the arrow is given in this direction, but we are going in the opposite direction of the current, so it will be minus Q into I2, and that is equals to 0. Okay, Pi1 minus Qi2 equals to 0, or we can write Pi1 minus qi2 equals to 0, or pi1 equals to qi2 and p by q equals to I2 by I1. Okay? So, P by Q equals to I2 by I1. P by Q, upper by down, equals to down current divided by upper current. Okay? So, why it is important? Because next loop, we will just apply it without solving. Okay? Now, similarly, from loop BDCB, So, from this loop we can write upper divided by lower, that is R by S equals to lower current divided by upper current. Okay? So, suppose this is equation 1, this is equation 2. So, if you compare 1 and 2, you get P by Q equals to R by S. This is the derivation for Wheatstone bridge. Very simple, easy derivation. This is the easiest derivation of all the derivation, and if you practice it, you can do it easily. Derive the expression for magnetic field at a point on the axis of a circular current loop. This is the last derivation I am suggesting. Hopefully, you will get at least true derivation out of these three. Now, here you have to simply take the loop, and then you have to, this is a diagram related question, so be very careful. This is radius of the loop, which is given by capital R, and here you join this point, this is small r, this is x. Okay, and remember that the magnetic field will be at some angle. Just remember it. If you understand, you want to understand, you can go and check my long form videos, but here I am just telling you, you have to remember that this will be at some angle, and this will be dB, this angle given by phi, then this angle will also be phi. Okay. Now what you have to consider that what is dB. So, from Biot-Savart law that we have learned previously is mu naught by 4 pi I into this small dl. Okay, sin theta is 1 over here, it is 90 degree angle, so sin 90 is 1 divided by r square. And because dB is at an angle phi, we have to take a y component and an x component. Okay, so in this case the y component will be cancelled, because if you consider this dl and this dl both, then the dl because of this will be in the upward direction, dl because of this it will be in the downward direction. So, y component will cancel, only x component will be there. So, only x component you need to consider for this derivation. Okay. So, dbx you have to consider. Very simple, easy derivation, step by step, and here you have to add the term cos phi. Okay, cos phi is the x component. So, it will be mu naught by 4 pi I into dl. Don't worry about dl right now, we will solve it, r square. Now, what is cos phi? Cos phi is r by small r. Okay, small r, base by hypotenuse. So, base is capital R, hypotenuse is small r. So, this is the formula. Now, simplify it, mu naught by 4 pi, okay, I dl r divided by r cube. We will put the value of r cube. We know r is here, x is here, x is the distance from the center of the loop. So, small r is actually unknown. So, we have to simplify it like this, and we have to put this value later on, right? Not right now. Now, what? Again, whenever I say Bx, if you have to find the total quantity, always integrate. Now, in this case, we will not put any limit. Okay, limit is not required. This is a general formula, as it is a closed loop. If you start from here, you have to end it here. This is the closed integration. So, starting point and ending point both are same, because it's a circular path. That's why we can do it. If it is a closed loop, we can apply this closed loop formula. Now, put the dBx value. Now, mu naught by 4 pi is a constant, so we do not need to put it inside the integration. Okay, again I r by r cube, they are all constant. So I r by r cube, they are all constant. So I am writing it outside. Only thing which is changing here is the dl, right? Dl can be taken at each and individual points, and then you have to add them. So integration is basically addition. Okay, so if you take small portion from all of the circle, you will get the total circumference of the circle. So close integral dl basically represents the circumference of the circle. What is the formula for circumference of a circle? It is basically 2 pi r, right? So I r divided by r cube into 2 pi r. This is the circumference. Okay, so 4 pi, 2 pi cancels, you get 2 over here, there is a 4 pi over here, this is a mistake from my side. So it will be mu naught by 2 I r square. Now it is time for us to put this value. So it will be square root of r square plus x square to the power cube. Now this can be intelligently be written as mu naught by 2 I r square divided by r square plus x square to the power 3 by 2. Okay, so this is the magnetic field, x component of the magnetic field. So just write it down, and if you do this, you will get full marks. So this is the first, this is the second. Okay, now let me know how was your exam, and if this video helped you or not after your exam is over. I'll be eagerly waiting, and all the best for your upcoming exam.